Welcome to Nihal Academy. This is your physics mentor Pawan. Now this is the part 2 of the high weightage questions. So these models are continuously repeating in the NEET examination. So students, those who are attending for the RE-NEET examination, so please practice all these problems. Don't skip it, okay? If the momentum of your body is increased by 50%, then the percentage increase in its kinetic energy is. So your initial momentum is P1 and the final momentum P2 is equal to how much 50% is increased from its initial. So P1 plus 50% of P1. So 50% of initial, that is P1. So from this P1 plus 50% means 1 by 2. So 1 by 2 means 0.5 P1. So P1 plus 0.5 P1, it is equal to 1.5 P1. So this is P2 value. And we know the initial momentum is P1. So we know the relation between the kinetic energy Ke is equal to P square by 2m. The same mass of the body, so m is constant. So by using this formula, we'll apply to the two cases, that is Ke1 is equal to P1 square by 2m. P1 square by 2m. And in the second case, it is equal to Ke2 is equal to P2 square by 2m. So same body, so masses are constant. Now we'll take the ratio of these two. So that is Ke1 by Ke2. It is equal to, so this P1 square by 2m. P1 square by 2m into, we'll take the reciprocal of this value. So that is 2m by P2 square. So 2m cancel. So this is equal to P1 square by P2 square. We know the P2 value, it is equal to 1.5 P1. So we'll substitute here. Then Ke1 by Ke2, it is equal to P1 square by 1.5 P1 whole square. So this is equal to P1 square by 1.5 means, that is 15 is 225. So 2.25. So 2.25 P1 square. So P1 square is cancelled. Now this is equal to 1 by 2.25. So this is Ke1 by Ke2. So from this, how can you write the Ke2 cross multiplication? So Ke2 into 1, Ke2. So Ke2, it is equal to 2.25 into Ke1. So we got the kinetic energy in the second case. So now, how can you calculate the percentage increase? We know the formula. So percentage increase, it is equal to Ke2. So it is equal to K. So that is Ke2 minus Ke1 divided by, so that is initial kinetic energy Ke1 into 100. Here already kept the percentage symbol, so we should not give the percentage symbol here. Now from this, so Ke2 is equal to 2 point, so that is 2.25. 2.25 Ke1 minus Ke1 by Ke1 into 100. So 2.25 minus 1, so that is equal to 1.25 and Ke1 by, this is initial kinetic energy into 100. Here Ke1 we can cancel. So this is now 1.25 into 100. So decimal after 2 digits, and here 2 zeros, so we can remove the zeros and decimal, then simply write the number, that's enough. So 125. So what is the percentage increase? So increased. So increased, it is equal to 125%. Now the second problem is, three masses are placed on the x-axis, 300 grams at origin, 500 grams at x is equal to 40 centimeters and 400 grams at x is equal to 70 centimeters. The distance of the center of mass from the origin is. Here the points are given. The first point is origin, so that is x1 is given 0, and the x2 is given 40, x3 is equals 70 centimeters, and m1 is 300, m2 is 500, m3 is 400. Now it is asking to calculate center of mass. M, it is equal to m1 into x1 plus m2 into x2 plus m3 into x3 by total mass m1 plus m2 plus m3. So by using this formula we can calculate the center of mass of the given points. Now m1 is 300 into origin means that is 0, x1 plus m2, so that is equal to 400 equal 0, and this is m2, and this is the point x2, and this is m3, and this is x3. So 300 into 0 plus m2, 500 into 40, 500 into x2 is 40 plus m3, 400 into x3, that is 70, by m1 is 300 plus m2 500 plus m3 400. Now this is equal to, the first term it will become 0. So 0 plus 5 fours 20, after 1 2 3 zeros, plus 4 sevens 28, after 3 zeros, by 300 plus 400, 300 plus 500 plus 400, 3 plus 5 8, 8 plus 4 12, after 2 zeros. Now this is equal to, this is 20,000 and this is 28,000, so it is equal to 48,000 by 1200. 2 zeros cancel. Now 12 here 4 times cancel, and here 0, so 40 times equal to 40. So what we have calculated, center of mass xcm, it is equal to 40 centimeters. So this is the answer, 40 centimeters. Center of mass from the origin, that is equal to the distance of the center of mass. The distance of the center of mass from the origin is 40 centimeters. Now we'll see the third question. From a circular ring of mass m, this is a circular ring, its mass is m, and radius r, its radius is r. An arc corresponding to 90 degrees sector is removed. This is the part removed. The moment of inertia of the remaining part of the ring about an axis passing through the center of the ring and perpendicular to the plane of the ring is k times mr square. Then the value of k is. So when the sector part is removed, the momentum of the remaining part, so that is, for example, so the remaining part, so is asking to calculate the k value, and here he has given the clue, the momentum of the remaining part. So after removing the sector, so that is remaining part, we'll take it as a, it is equal to P2, and the removed part is equal to P1. So now we know the momentum of inertia of the full circle. So what is that? That is I, it is equal to, this is the momentum of the full circle, it is I is equal to m r square, because it is the form of circle. So the moment of inertia of a circle, it is equal to m r square. So now here the first part, removed part, so P1. So for P1, momentum of inertia, that is I1 is equal to, small m is the mass of this removed part. So m r square. What is this m? This m we have to calculate by using this. So m, it is equal to remote, the mass of the remote part m is equal to, this is 90% of the 360. So 90 degrees by 360 of m, capital M. So this is 4 times cancel, that is equal to capital M by 4. So this is the mass of removed part. So that is M is equal to M by 4. Now this is equal to capital M by 4 into R square. So this is I1. So we calculate I1. Now what we have to calculate? K value for P2. For P2, moment of inertia I2 is equal to I, we can write as momentum of inertia of the full circle I minus I1. So this is I2, we can write it as moment of inertia of the full circle minus moment of inertia of the sector. Then we will get the moment of inertia of the remaining part, that is I2. So this is equal, I is equal to mr square minus I1 is equal to mr square by 4. mr square by 4. So this is equal to, so 4 is the LCM and here 1. So 4 times. So 4 into mr square. So 4 mr square minus here 4. 4. 1 time cancel. So 1 into mr square, mr square. So now this is equal to 4 mr square minus mr square, that is 3 mr square. 3 mr square by 4. So now we got I2 is equal to 3 by 4 mr square. But as per the problem, as per given problem, I2 is equal to k mr square. As per the given problem, I2 is equal to k mr square, k times to the mr square, so k mr square. Now compare these two. So compare these two. In the place of k, 3 by 4. So by comparison, therefore, k is equal to, when we compare these two, so k is equal to 3 by 4. K is equal to 3 by 4. So k value 3 by 4. And now we will see the fourth question. Two disks of same moment of inertia rotating about their regular axis, passing through center and perpendicular to the plane of disk with angular velocities omega 1, omega 2. So angular velocities are given omega 1, omega 2, and they have the same moment of inertia. And next they are brought into contact face to face, coinciding the axis of rotation. The expression for loss of energy during this process. Loss of energy we can write delta K, it is equal to Ki minus Kf. So Ki we have to calculate. So to calculate Ki, so we can write it as half, the kinetic energy initial is equal to half I omega 1 square. So they are separated initially, plus half I omega 2 square. Here half I is a common, so half I you can take out common, then omega 1 square plus omega 2 whole square. So this is Ki. Now we have to calculate that Kf, it is equal to, now Kf is the final kinetic, so then here it is, so in this case, so the two are in contact, so they brought into contact face to face, so that is final. So then half 2I omega square, here 2 cancel, then Kf it is equal to I omega square. Now here we have to calculate the omega square. So as per the law of conservation of angular momentum, as omega 1 plus I omega 2, it is equal to 2I omega. So I you can take out, then omega 1 plus omega 2 is equal to 2 omega. So this omega we can write it as omega 1 plus omega 2 by 2. If you substitute this value in this final, so kf it is equal to I omega square. So this is equal to I omega square means omega 1 plus omega 2 by 2 whole square. Then this is equal to I by, so 2 square, that means 4 into omega 1 plus omega 2 whole square. This is kf. So now by using these two, we can calculate the loss of energy, that is delta K is equal to Ki minus Kf. We calculate Ki and Kf. By using these two, we can calculate the delta K. So delta K it is equal to Ki minus Kf. Calculate this difference, that is equal to the loss of energy. Delta K is equal to Ki. So I by 2. I by 2 omega 1 square plus omega 2 square, omega 1 square plus omega 2 square. Next minus kf I by 4 omega 1 plus omega 2 whole square, I by 4 omega 1 plus omega 2 whole square. So this is equal to, we'll take it common, I by 4. So I by 4 is taken out, then here I by 2, so we can write here it is a 2, and this is here 2 into omega 1 square plus omega 2 square, and here minus I by 4 is taken out, then this part is left. So omega 1 plus omega 2 whole square. Now we will simplify I by 4 into, this is 2 into omega 1 square plus 2 into omega 2 square minus a plus b whole square expansion, a square plus b square plus 2ab. So a square means omega 1 square. So minus omega 1 square. Next minus omega 2 square minus 2 omega 1 omega 2. This is here. Now from this, I by 4, 2 omega 1 square minus omega 1 square, that is equal to omega 1 square, and next 2 omega 2 square minus omega 2 square, that means plus omega 2 square, and here minus 2 omega 1 omega 2. So this is equal to I by 4 a square plus b square minus 2ab. So omega 1 minus omega 2 whole square. This is loss of energy delta K. So it is equal to I by 4 into omega 1 minus omega 2 whole square. The fifth question. If a sphere is rolling, the ratio of the transitional energy to the total kinetic energy is given by. A sphere is rolling, so transitional energy ET will represent, and the total kinetic energy. So energy, so this is total kinetic energy. So K, EK is the total kinetic energy. So this ratio I have to calculate. So what is this transitional energy? So ET it is equal to of mv square when a body moving in transitional path. So now EK we have to calculate. So EK it is equal to this total energy, it is equal to the, so transitional energy ET plus rotational energy ER. So ET is equal to of mv square plus rotational energy, so of, it is equal to I omega square. Here I is the momentum of inertia of a sphere. So 1 by 2 mv square plus 1 by 2. I is the moment of inertia of the sphere. It is equal to 2 by 5 m r square, and omega, so this is omega square, and 2 cancel, so this is equal to 1 by 2 m v square plus here 1 by 5, this is m r square omega square. So this is E K. See, V is equal to R omega. So for squaring on both sides, this is V square is equal to R square omega square. So instead of R square omega square, we can write V square. So this is E K, it is equal to half M V square plus E square plus 1 by 5 M R square omega square, it is equal to V square. So we can replace with V square. So this is mv square is common, so we can take out common mv square. Here it is 1 by 2 plus 1 by 5. So this is equal to mv square into, so LCM is 10 and 2 here 5 times 5 into 1, 5 plus 5 2 times 2 into 1, 2. So 5 plus 2 by 10. Now this is equal to mv square into 5 plus 2, 7 by 10. So this is equal to ek, it is equal to mv square into 7 by 10. Et is equal to half mv square. We will take the ratio of these two now. So et by ek, it is equal to half mv square by ek, it is equal to 7 by 10 mv square mv square cancel. Now this is equal to 1 by 2. This will take it as a into and write the reciprocals. 7 by 10, it will become 10 by 7. So 2 5 times cancel. So this is equal to et by ek 5 by 7. 5 by 7. So this is the ratio Et by, so that means the ratio of transition energy to the total kinetic energy, so that is equal to 5 by 7. Now also the sixth problem, a geostationary satellite is orbiting the earth at a height of 5 or above the surface of the earth. So that means, for example, this is the earth and its radius is r and it is 5r. So from the surface, the first one is 5r distance. This is first one. Okay, satellite. R is being the radius of the earth. The time period of another satellite in hours at a height of 2r from the surface of the earth. The second one is, so from the surface of the earth it is with 2r distance. So this is second one. Now here this is also r distance to the surface. Now, so we can understand that the total distance of the first satellite is r plus 5r, that is equal to 6r, and the second one is r plus 2r, it is equal to 3r. So now, so what we have to calculate? The time period of the second satellite. So the relation between the time period and distance r, it is T square is directly proportional to r cube. So we know this relation. So we'll apply to the two satellites. So T1 square by T2 square is equal to R1 cube by R2 cube. So R1, here R1, here R1 it is equal to r plus 5r, it is equal to 6r. R2 is equal to r plus 2r distance, so that is equal to 3r. And we know that T1 time period of first satellite is equal to, so 24 hours. That is, we'll take this relation, T1 square by T2 square is equal to R1. This is, we can write it as R1 by R2 whole cube. R1 cube by R2 cube. So we can write it as R1 by R2 whole cube. So R1 by R2 whole cube. So T1 square means 24 into 24. So 24 into 24 by T2 square. T2 square is equal to R1. R1 is equal to 6R. 6R by R2 is equal to 3R. 3R whole cube. So R cancel and 3 here 2 times cancel. So this is equal to 2 cube. So this is, from this we can write it as T2 square is equal to, T2 square is equal to 24 and 24 by 2 cube. So 24 into 24 by 2 cube. So this is equal to, so 24 into 24 by 2 cube means 8. 8, 3 times cancel. Now 24 into 3. So this is, we can write as 24, we can write as 8 into 3 into 3 into 3. So 24 we can write as 8 into 3 and here 3. So this is equal to 8, we can write it as 2 into 4, 8. So 8 we can write as 2 into 4 and 3 into 3. 3 into 3. Now we have to calculate T2. So T2 is equal to, this is square. So if you apply the square root, then root of 2 into 4 into 3 into 3. So this is equal to, here square root of 2 into 4 into 3 into 3. So square root of 4, it is equal to 2 into 3 into 3. So that is equal to 3 root, and what is left here? 2 is left. So now this is equal to, so therefore T2 is equal to 2 3 is 6 and root 2, 6 root 2. Now also the seventh question. The escape velocity of a body on the surface of the earth is 11.2 km per second. So escape velocity of the body is given 11.2 km per second. If the Earth's mass increases to twice to its present value, that means Earth's mass is m means, so it is doubled. So 2m. The radius of the Earth becomes half. That means r, it will become r by 2. The escape velocity would become, so now we have to calculate the escape velocity after changing mass and radius. E is equal to, you know the formula, square root of 2gm by r. Now here m value is doubled. M value doubled means that is m dash is equal to 2m. And radius is half of the radius, so r dash, it is equal to half of the initial radius, that is r by 2. Now we have to calculate that escape velocity, so after changing mass and radius. So this, then v dash e is equal to square root of 2 g m dash by r dash. Here g is constant, 2 is constant. So from these two we can write VE dash by VE is equal to, VE dash means square root of 2 g m dash by r dash into, so divided by, we can take it as a reciprocal. So then the reciprocal of this VE, it is equal to square root of 2gm by r, it will become r by 2gm. So root m into root n, so it is equal to root mn. So we can write it as a 2g m dash, it is equal to 2m by r dash, it is equal to r by 2. We will replace that value as r by 2 into, this is r by 2gm. Now here 2 and this 2 is cancelled, m cancel, g cancel and r cancel. Now this is here square root of 2 divided by 1 by 2, 1 by 2. So this 1 by 2, so we can write it as 2. So this is the denominator plus 1 by 2. So we can write as into, then 1 by 2 will become reciprocal, so 2 by 1. So that is equal to 2 by 1 means it is equal to root 4. So root 4 means value it is equal to 2. So therefore VE dash by VE is equal to, that means VE dash is equal to cross multiplication 2 into VE. So 2 into VE. So 2 into VE is equal to escape velocity, that is equal to 11.2. 11.2. So 2 into 11 that is equal to 22.4 kilometer per second. Kilometer per second. So this is VE dash. So this is answer 22.4 kilometer per second. See the eighth problem. The acceleration due to gravity at the height 1 kilometer above the earth is the same as at a depth alpha below the surface of the earth. Then, so that means the acceleration due to gravity above the earth, so that is 1 kilometer height, it is equal to the depth alpha below the surface of the earth. So what is that acceleration due to gravity above the earth? G H is equal, what is the formula? G into 1 minus 2h by r. So this is the formula. H is the height, r is the radius of the, G is the acceleration due to gravity. Now we have to find out that depth. So acceleration due to gravity at depth, so that is G alpha, it is equal to G into 1 minus d by r. D is the depth. As per the problem, these two are equal. That means GH is equal G alpha. GH is equal G alpha as per the given problem. Now we have to equate right side parts, these two. That means G into 1 minus 2H by R, it is equal to G into 1 minus D by R. Here G cancel. Now the remaining part is here 1 minus 2h by r is equal to 1 minus d by r. So 1 minus 2h by r is equal to 1 minus d by r. 1 cancel and minus we can take out same, and now this is equal to 2h by r is equal to d by r. R is also same, the radius of the earth, so we can cancel, then 2h is equal to d. So d we have to calculate, d is equal to 2 into h as per the given problem 1 kilometer. We'll substitute that h value 1, so then it is equal to 2 kilometers. So this is d value here. So as per the problem, h is equal, d is equal to 2 kilometers. The next question, that is 9. Two wires are made of the same material. So same material means, so then Young's coefficient is same. So that means y is equal to y dash and have the same volume. So v is equal to v dash. The first wire has cross sectional area A and the second wire has cross sectional area 3A. Second wire area of cross section A is equal to, A dash is equal to 3A. So that means A is the first wire cross sectional area. If the length of the first wire is increased by delta L on applying a force F, how much force is needed to stretch? So we have to calculate that F dash to stretch the second wire by the same amount. That means delta L dash, the amount of increase, that is delta L dash is equal to same amount, so that is delta L. So from the given question, y is equal to y dash, volume is equal, v is equal to v dash, and a dash is equal to 3a. We have to calculate f dash, and delta L dash is equal to delta L. So now here we have to calculate the length by using this relation. So v is equal to v dash. So how can you write the volume? Area into length. So area into length. So this is the first wire, and the second wire A dash into L dash. So now area of the first wire is A and the length is L, and the second wire area it is equal to 3A into L dash. We have to calculate. So from this information, here A cancel, so then 3 into, so from this we got L is equal to 3 into L dash. So L dash is equal to L by 3. L dash is equal to L by 3. So for the first wire, how can you write the Young's modulus? So Y is equal to F by A into L by delta L. So for the second wire, Y dash is equal to F dash by A dash into L dash by delta L dash. So here from the given information Y is equal to Y dash. So these two are equal. So we have to equate RHS side part. So that means F by A into L by delta L is equal to F dash by A dash into L dash by delta L dash. So now we'll substitute that information. So that is A dash is equal to 3A and L dash is equal to L by 3 in this formula, and delta L is equal to L dash. Delta L is equal to L dash. F by A into L by delta L is equal to F dash by A dash into L dash by delta L dash. Now we'll substitute this information here. So F by A into L by delta L is equal to F dash by A dash 3A into L dash, that is L by 3, L by 3 by delta L dash is equal to delta L. So now either side A we can cancel and L we can cancel and delta L we can cancel. Then F is equal to here F dash by 3 into here 1 by 3. So 1 by 3. So from this F is equal to F dash by 3 into 3, 9. So what we have to calculate? F dash we have to calculate. So F dash is equal to cross multiplication. So 9 into F. So this is the answer. F dash is equal to 9 times to the force applied previously. So that is 9 times. So F dash is equal to 9 times. 10th one, a black body at 227 degrees Celsius radiates heat at the rate of 7 calorie per centimeter square second. At a temperature of 727 degrees Celsius, the rate of heat radiated in the same units will be. So heat radiated is given, that is E1 is equal to 7 calorie per centimeter square second, and the temperature T1 is given, and this temperature T2 is given, is also calculate. So radiated energy in the second case, that is U2. So here energy radiation and the temperature relation is from the Stefan's formula. Stefan's law, E is equal to sigma T power 4. So this is the Stefan's law, that is energy radiated and temperature relation. So now by using this, so E1 is given, E1 is equal to 7 calorie per centimeter square second, and here temperature, so that is T1 is equal to 27 degrees Celsius. This we have to convert into absolute temperature, that is T is equal to 227 plus 273. So if you add these two, 10 and this is 10 and 4 plus 1, 5. So 500 degrees Kelvin. So this is T1. So T1 is equal to 500 Kelvin. Now T2 is also given. So T2 is equal to 727. So we have to calculate absolute temperature. So T2 is equal to 727 plus 273. So this is equal to 7010. So 10 and 1, 10. So 1000 Kelvin. So this is T2. So T2 is equal to 1000 Kelvin. Now we will apply this formula in the two cases. So then E1, it is equal to sigma T1 power 4 and second case E2 is equal to sigma T2 power 4. Now if you take the ratio of these two, that is E1 by E2, so then it is equal, here sigma cancel, so E1 by E2 it is equal to T1 power 4 by T2 power 4. So the exponent is same, so you can write it as E1 by E2 it is equal to T1 by T2 whole power 4. Now we'll substitute that T1 T2 values. So T1 500, T2 1000. So 500 by 1000. So 500 here, 2 times cancel, and this is power 4. That means 1 by 2 whole power 4 means 1 by, so this is 0. So E1 by E2 is equal to 1 by 2 whole power 4. So this is equal to 1 power 4, that means 1 by 2 power 4. Now E1 is given 7 calorie per centimeter square into second. Now substitute the 7 here. 7 by E2 is equal to 1 by 2 power. Now 7 by E2 is equal to 1 by 2 power 4. So cross multiplication from this E2 into 1. So E2 is equal to 2 power 4 into 7. 2 power 4 into 7. So this is equal to, so 2 power 4 into 7. So this is equal to 2 power 4 means 16 into 7. So 16 sevens, 7 6 42. So 2 4 7 1 7 7 plus 4 11. So E2 equal 112 calorie per centimeter square second. So this is the energy radiated in the second case. So E2 is equal to 112 calorie per centimeter square second. The question number 11, a black body has maximum wavelength lambda m at temperature 2000 Kelvin. Its corresponding wavelength at temperature 3000 Kelvin will be. So we have to calculate the corresponding wavelength, that means lambda m dash. The temperature T1 is given, T2 is given. So what is the relation here? The maximum wavelength and temperature. So we know that the maximum wavelength into temperature is equal to constant. So from this formula, I will apply to the two cases. Formula lambda m into T is equal to constant. The temperature T is given, that is equal to 2000 Kelvin. And the second case is also given, that is, we will take it as a T dash, it is equal to 3000 Kelvin. Now we have to calculate the maximum wavelength for the 3000, that is lambda m dash is equal to question mark. So we'll apply this formula in the two cases. Then lambda m into T, so this is constant, so is equal to constant. And in the second case, the formula lambda m dash into T dash is equal to constant. And in the right side, both are constant, so equal, so we can equate the left side. Left hand side will equate, then lambda m into T. Lambda m into T, it is equal to, here this is lambda m dash into T dash. Now we will substitute the values. So this is lambda m into T, it is equal to 2000 is equal to lambda m dash into T dash is 3000 into 3000. Here zeros, 0, 0, 0, 0 cancel. So from this lambda m into 2, this 3 will bring to this side, then 2 by 3. So is equal to lambda m dash. So lambda m dash, it is equal to, so 2 by 3 of lambda m. So that means the maximum lambda m. So this is, so in the second case, maximum wavelength, it is equal to 2 by 3 times of maximum wavelength in the first case.